Hello, everyone. I'm Murli Shankar, a senior solution architect here at AWS. I've been with AWS for past 2 years, in the industry for 22 years. Prior to this role, I worked with a system integrator focused on data modernization, and migration. And here with me today is my esteemed colleague, John, who is a principal architect at AWS. John, you want to say a few words?
Yeah. Hey, everybody. John O'Donnell. I've been at AWS a little bit over 6 years. As Ron mentioned a little bit earlier, actually, my first big engagement here was working with Vanguard and kind of their move to the cloud and their, the sophistication and the amount of data that they moved into AWS is truly astonishing, right? So um, but yeah, so I'm here to join Morale, right, to kind of go over these things. Morale's gonna go first. I'm gonna pick up second, and we'll talk soon. So thanks.
Thank you, John. So data architecture play a pivotal role in today's enterprise. We know it. It is the backbone of the transformation. A well-structured data architecture is the foundation upon which AML can thrive. So if I look at my financial service customers that across all segments, whether they are in the capital market, insurance, mortgage, or payment, all of them have leveraged AWS to modernize their analytical capabilities. Financial institutions today have numerous challenges. Data growth is one of them, and ever-changing compliance requirement, not to mentioning the evolving customer expectations. So the timeline I put it here, as you can see, there are various use cases. If you look back to the timeline in 2014, 15, and 17, most of the use cases were about post-trade analysis and trade surveillance and reporting and out of your existing data. Now we are witnessing a new era of innovation driven by AI/ML, and this is actually reshaping the entire financial institutions and how they collect, how they process, how they analyze, and what insight they can generate from this. And we will look at that in the next few slides. So what is all these use cases mean to us, right? The data analytics is not merely a tool, it is the key to stay competitive in the business. So let's look at the transformative power of data and analytics. Most of the organization have data, and most of the organization have some complex ecosystem. So analytics allow us to see and understand every facets of this complex ecosystem. A comprehensive understanding of data is paramount. It's not limited to the collecting to the data. It is collecting the data, creating a 360-degree view of the data and painting a big picture. And you need to collect. For that, you need to collect and create a touch point across all the data and create a consistent user experience. So for the analytics of data, we talked about the growth of data. This need huge computing power, right? And we are processing a vast amount of the data today in a short period of time. That is the requirement in most of the enterprise. That is where AWS infrastructure and services that's come in handy. Our services and infrastructure ensures that customers can handle the data overload very efficiently. And with AI/ML now, you can analyze the data in a way that were previously unimaginable, whether it is the contact center management, predictive analytics, or creating a voice and chatbot. And there are new ways that we can unlock the data potentials. So what we are going to do today in the next couple of slides, we are going to look at the modern data architecture in detail. In this session, I will cover the three topics: why modern data architecture and the key principle and some real world use cases. So let's jump right into that. So we talked about the volume of data and the growth we are seeing. What we are also seeing, the new type of data that is coming in. there are a lot of unstructured, semi-structured data coming from various devices today, whether it could be your mobile or your social media feeds or your IoT devices. We are seeing lot more variety of data. Likewise, as the data growth and volume increases, we are seeing new trend in the way the data is consumed. Now, customers are moving beyond the traditional dashboard and report format. Predictive ML and real-time predictions are a reality now. As the business come more and more or data-driven, the type of stakeholders are also increasing. Everyone needs data at some point to process and make some meaningful output from that. And these trends means that performance, manageability, and scalability take a center stage, and that's become critical to the business. Not to mention with the volume of data and the cost become very unpredictable because we have a flux in where the data coming. So predicting the actual cost is also a real challenge. The traditional tools that we use for data analytics, which we will look that in a minute, that are not often they are not very flexible. They are great for certain use cases and they are continue to be a value in that, but they are unable to scale and accommodate the new variety of the data that is coming, and they are not able to tap into the new sources of data that business need. I am sure none of this is a surprise to you. These challenges you will see almost day to day in your day-to-day operation. So how do we solve this problem? That is what we are going to look at next. But before we jump into how we are going to solve the problem, let's look at how we traditionally operated, and many companies continue to operate in this way as they make their transformation journey. Traditionally, in data and analytics, we have used data warehouse. And we all know the core and center of the data warehouse is a traditional RDBMS systems, where we will collect data from multiple sources, process it, and then upload to the data warehouse. And then after that, we will use a business intelligence system or traditional reporting system to take some data out of it, some insight out of it. So the traditional data warehouse, it has delivered value through the reporting and BI, and it continued to deliver value in certain section of the business. However, these systems are not very friendly when it comes to semi-structured, unstructured data. Some of them cannot be fit in. Even if you want to fit in, you need to do a major transformation before you actually load. That take time, that will take out your flexibility, and this have extensive cost. Not to mention, data warehouse system by itself are CapEx heavy, and you need a lot of upfront investment. And generally, the data warehouse system, if you look in the market, they are good from anywhere between terabytes to petabyte, but when it cross the petabyte, it really doesn't scale. Then that is why we have a new way of looking the systems. So the data lake are the next evolution of the analytics platform. What does data lake help us to solve? It solves many challenges, especially in the scale of data. And with data lake, your data, all data, whether it is structured, unstructured, semi-structured, it's all stored in one place and queried from one place. We are actually in the data lake, we are decoupling the storage and compute. That is why we are able to scale the data lake the way we want. And the data lake take an approach we called schema on read. We talked about earlier how we load data into the data warehouse. Generally, all the time you pre-process the data and load the data. But when it comes to data lake, with all kind of data, you just dump to the data lake or load to the data lake, and you can continue to process. If there is a requirement to further cleanse and reprocess the data, you can continue to do that. There is no pre-processing when it comes to the data lake. This is one of the main concern I hear from most of my customers. One of the challenges when you design a data warehouse, it takes a lot of time because you need to fit your schema for your future. So you need to look at the requirement for next to 2 to 3 years or even 5 years, design a schema, define your transformation process, and load the data. But that is where data lake comes in handy. You can actually immediately start loading your data, but whatever format it is, and then you can start deriving insight from it. So let's look at some of the key principles that drive this. We talked about the scalable data lake, and let's also look at some of two of the key principle, which is purpose-built data service and seamless data movement. So all of this principle, it's basically it allow you to choose the best breed of purpose-built services as the use case, whether the data is in your warehouse or it is in a data lake or in your partner system. These principles else you can leverage. So let's look at these two principles in a little bit more detail. The one I want to cover as first step is the purpose-built service. This allows you to meet the right balance between performance and the cost. Let's look this into little bit more detail. There are two outcomes when data becoming the core of your business. One is there are more use cases that business want to use. Second, there are more people with different personas want to use and consume this data. From the use case standpoint, companies need to use the data in a more innovative way, and they want to unlock the potential. From a people standpoint, more people with different personas want to consume this data in a short time. So the challenges are multiple here. One is how do we give the right access to the right people? How do we secure the data? How will make sure there is no data leakage? That is one. And it also means that there is no single tool that can efficiently and effectively address all of these concerns. Okay. That's why purpose-built data services enable this by giving stakeholders the tools and data that need for their use cases. It could be one AWS, for example, it could be AWS SageMaker for your AML related work, or Redshift for your data warehouse, and many more. But this approach has its own challenges, right? Now we have a huge data, different type of data, different users need this data in different format and different times. So that actually create a complex as data movement issue or complex ETL in our traditional way to look at this. So how do you move data between these services without creating a complex data pipeline? That leads to the next principle of seamless data movement. So seamless data movement really enable purpose-built approach by making simple and easy to move data. As we know, data has a gravity, it resists for movement. As the data grow, doesn't matter if this is your traditional database or a NoSQL or a data lake, as it grows, it's very difficult to move the data around. And also it's important, we need to ensure that data can not only move easily, we need to have the right control. So if you look at in the modern data platform, we need to able to move the data around in a seamless and frictionless manner. With this approach, we want to move only the subset of the data, whatever the particular user persona need, and using that purpose-built service we talked about. And we look at the data movement at a high level in three general patterns. One is inside out. That is from your core data lake to your periphery system, whether it's a NoSQL or a data warehouse. Second is outside in. For example, you loaded your data to a data warehouse, ran some queries, and where you want to store the data. You want to store the data back in the data lake so that other systems can consume it. That is an outside-in movement. Then we are seeing use cases where for in our customers, where customers has to move the data around. For example, you have tons of log coming from web application. You want to process that using a big data processing. That is moving the data between your peripheral system. So this modern data architecture and platform enable it provide you flexible tool, it provide you manageability, and it give you the performance that you are looking for. So now take a look at a typical cloud journey that what we are seeing in our customers. Always the starting point is get familiar with the cloud. You create some systems, get familiar with that, build a foundation service, understand and address the security concerns you have and compliance requirement in detail. The next stage generally is start analyzing the data, plan for your scalability, and look at your cost structure and separate the storage and compute, which we talked about earlier. And as you move through this journey, you can unleash the intelligent insights through AI/ML. This is where the transformation from analyzing historical data to making prediction and uncover hidden patterns. That is what happening in the AI/ML side. And AWS flexibility and scalability enable businesses to experiment and innovate with data and AI/ML. So that said, let's look at a real world use case. And this is a US-based customer, and they provide liquidity to the housing market. They were running multiple data warehouse in their on-premise system. This is the exact issue I was talking about, the data silos. You have a structured data, you have unstructured data that doesn't fit into your data warehouse. So they have multiple silos in their on-premise environment. So what they were looking at that time, it was a self-service, a dynamically scaling environment, and an option to share data with other businesses and application and central source of data. They started with AWS Data Lake, a 100% native data lake, and that provided the platform and capabilities they were looking initially. As they found that the central database, they can do much more analysis, they decided to tap onto the AI/ML journey. So they use Amazon SageMaker to find out who is going to default on my loan. Basically, they want to find out what is the potential for a particular user who's going to, or end customer who's going to default on their loan. So they created an AI/ML model that predict the probability or the chances of a loan getting default. So if you look at there some statistics before the data lake and before having this ML model, they were catching less than 4% of the loans going to get default. Now they are at 48%. So you can see how this entire model is helping business to better risk management and secure their business, so that business can go and look at and mitigate those risks much earlier and much in higher number. So this is the value that we are seeing in our customers. This is one of the use case. There are many more use cases, but let's look into the AI/ML journey. So I'll invite John and to walk us through the ML journey here. John?
Great, thanks. Thanks, Murali. That was excellent. Yes, we're going to cover basically generative AI, which I'm probably sure everyone's heard of, right? Machine learning, kind of go over that. But what's really critical, the one thing you need to have in place is a strongly governed data framework, like what Murali covered, right? It has to be modern. It can't be, a mess, right? Which a lot of companies tend to have, right? So to be successful in this area, you're going to have strong data governance and modern data architecture, as Murali covered, as said. So what traditional AI/ML, and I almost hate to say that because AI/ML isn't really that old, right? But the rate of change is only increasing, is still going strong. What is traditional AI ML? It's kind of, if you heard of kind of like training and things like that, it's traditional machine learning models that do one thing really, really well, right? So we have a service called Textract. It will take an image and pull text out of it, right? That's all it really does extremely well, but it can't do anything else. You ask it to create an image or what time it is, it's going to stare back at you. So what financial services companies are using in this space, right? And I actually was personally part of a project rolling out some of the first AIML into financial services. Customer experience, for example, is you call your broker, maybe you sound a little bit upset and you got an urgent question, right? They can use machine learning to kind of detect your sentiment, extract text from that, and route you to the right call center representative, right? If you don't want to talk to a call center representative, then you can, ask my balance and things like that. All that is behind the scenes. There's a fair amount of machine learning there. T. Rowe Price, if you've heard of them, they use Amazon Connect, which is our call center software, with built-in AI, so they can do automatic call routing based on if someone's calling back to the same number 3 times in a day. There's probably something going on that's wrong. We're going to route them to a higher queue. Personalization, where we're seeing this being used a lot as asset managers, wealth managers are leveraging machine learning to create personal portfolios based on individuals' goals, demographics, right? That's a big thing. Robo advisors are kind of similar, right? So they kind of take your preferences, your acceptance of risk, where you're at in life, right, and will generate a custom investment plan portfolio just for you. No two are exactly the same. Text analytics, again, this has been around for a while. You could, kind of like Googling things, you can extract, information from regulatory filings, summarize things, process documents, due diligence. And when you're doing investment, due diligence for creating investments, right? Siemens Financial Services use this to kind of plow through those, piles and piles of documents. Predictive analytics, this is, exciting area that you can basically, it's optimizing kind of trading patterns, making better trading decisions, leveraging things beyond simply the market, sentiment analysis, social media, video feeds, radio, right? Be able to take all those, put that in there and say, hey, what's the next, I'm hearing all this, not just pulling something from Twitter or X, whatever it's called today, right? But pulling from a plethora of sources. That's being done, and that's been very successful. And then I think another thing is fraud detection, anomalies, detecting that something's going on that's a little wonky, right? This thing's way, twice the threshold that we normally see. Let's flag this one. Someone's using a credit card in Uzbekistan or something, for example, where they're a U.S. citizen, resident. We're going to flag that, right? And that's where. So these are all kind of traditional AI/ML. So we go to the next slide. So everyone's heard of generative AI, but what is it? It's basically AI/ML that can create content. I won't go into all the technical nuances. That would require a whole nother session or two to go into how it works. But essentially, it creates new content. If you work with ChatGPT, write me a short story about dogs and cats or something, right? It can do that. That's what it does. And it can do that with images. It can do that with music. It can do it with anything, right? So it's been trained on this entire corpus, right? Literally the entire internet, or what they could search, right, is kind of put into these large models, right, to generate, to train it to come up with responses to requests. There, again, as I mentioned, lots and lots of text and data that creates a foundation model. And that's the word you'll hear about when you hear Anthropic, right? And Amazon and Google's investments into that. These guys just built this really cool foundation model, and they get billions of dollars for it. Not that easy. There's a lot of work that goes into that, a lot of cost as far as indexing, things like that. But that's what a foundation model is. And then when a foundation model is used on text data, it's what's called a large language model. So if you say, large language models are all they do. They're trained on language, right? The English language was primary. Other languages are also available where it knows all the ins and outs. So it can pull text out of documents. It can do all sorts of really cool things in a conversational way. Go to the next slide, please. So what are some, where's some value that you can drive in this industry? Goldman Sachs is saying that generative AI could raise global GDP by 7%. I mean, that's huge, right? That, the economic growth there, right? We're still in the very early days, I would say. This is, if you follow these things literally almost every day now, there's another new foundation model out there, large language model that's out there that's just eclipsing the previous one. So the rate of change is just kind of off the charts. And not all models are not created equal. Some are really good at doing some things and they're not so great at doing other things, right? It's just how they were trained, what their kind of purpose is, right? So there are very good general purpose models out there, right? But there's also ones that are very, very, very good, right, at certain, more tasks. Like, for example, Claude, which is an Anthropic model, can take 100,000 tokens. That's about 70,000 characters, right? It's huge. All at once, right? Where like most models like ChatGPT, I forget their limit now, it's something like 8K or something like that. So you think about like, so you would use Claude in a different way than you would use ChatGPT versus Titan versus other models, right? And just the productivity is you can literally go into ChatGPT or an Amazon Bedrock and say, write me some Python code to, connect to a DynamoDB database, right? Like kind of what Morale was showing, and it's going to write you code, right? Or, create a diagram in one of the image models that the AWS diagram to build out a modern data architecture. It'll give you something, right? So again, really cool stuff out there. Go to the next slide. So use cases again. What are we trying to do with customers? Customers are your lifeblood. If you don't have customers, you don't have a business, and well, in any industry, but certainly financial services are very competitive. Again, been there, still working with an insurance customer, right? But you want to improve internal and external customer experience. Where I've seen generative AI used first and foremost is internal use cases, much lower risk, much easier to get contact with the data, a lot less challenge with lawyers and whatnot, right? And I'll go with that in a minute. Efficiency of knowledge workers, right? Like financial services workers are very important to the success of the company, right? Some highly paid, traders and whatnot, right? You want information at their fingertips. And then just doing new things, product innovations, sentiment analysis, things like that. How can you develop a competitive advantage leverages technology versus your competition? So the next slide, please. So here's an example of kind of how would you do these type of things, right? So if we're going to improve the customer experience, this is just one example. Everyone's seen a chatbot. Everyone's probably getting tired of seeing chatbots on every website. Where what's really neat about that is I did research at a large financial services company that it's generational. The older folks like me, Morale, not saying Ron's older, right? But we prefer using the phone, right? Where the younger generations prefer to use, text or apps, right? So chatbots actually have a huge uptake generationally, right? Now there's coming out with chatbots that actually have voice assist, so senior citizens can use it. They can just talk to their computer and get responses back. So again, a great chatbots you'll see out there, and they're actually really helpful for a lot of people. Reducing actual phone calls to your call center is where chatbots are like a really sweet spot, right? Because if someone really needs to talk, you want to get in there as fast as you can. But if they say, hey, what's my balance? You can do that with a chatbot like that, right? And then, leveraging, so I have a customer who's working this, they have essentially an internal help desk that gets questions from customers, right? What we're going to do is we're indexing all their, requests and answers, right? And then creating a large language model on that so a customer can ask in plain text, like, how do I do blah, 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 right? It'll give them an answer with a link to the reference material, give them a step-by-step guide, right? So instead of having to call somebody or give up, even worse, give up on the product, they can get it, they can answer quickly. And again, knowledge articles is you're able to combine many sources of data. It's called retrieval augmented generation, but I can get data from a SQL Server database, a S3 bucket. I could query it a live API from another site, combine them all together, and come up with meaningful information. Next slide. So, wow, John, this sounds great. Like, why don't we start yesterday? There's some things you need to know, especially in this industry, right? Again, having done some of this, in the past, there's always risks to any approach that you take. You do nothing, there's a risk. You do something, there's a risk, right? But generative AI, if you're familiar with the term, is non-deterministic. Every time you run it, you could come back with a slightly different answer, right? You can tune that, you can change it, but it's because it's writing language, it almost, it's really glorified auto predict on your cell phone, right? It may not, if you run it 100 times, you may get 90 different answers, right? Slightly different answers, right? Even if you tell it not to. So that's certainly a risk. So if you need to have deterministic and fully explainable traceability, things like that, then that could be an issue. There's a term you may have heard about, it's called hallucination, where models just make things up, right? You can fix that, but you have to know when you're getting into this, you're not going to use generative AI to create, financial statements, right? No, don't do that. It can maybe give you a template or show you how to do it, but it's not going to create reports like that. I think obviously I heard it was an auditor on the phone, right? Other folks that are kind of looking at these things, right? You want to assess the risks and know what you're getting yourself into, right? As I mentioned, hallucinations, intellectual property rights. You want to make sure that, there's still case law has not been developed yet. If something's generated by generative AI, do you own it, right? And the question is, no one's really sure, right, at this point. And then monitor, like the EU just did a thing. There was an executive order the other day. Who knows where all this is going to go? Everyone's so hot on generative AI, they want to regulate it, right? So look into that. It doesn't mean you shouldn't try it and prototype it and do those things, but the regulatory roadmap is changing. And then the next slide, please. So this is a real world example of a company that basically created artificial investment associate, right? So what it did is it was an interactive tool for creating like very sophisticated charts, right? Letting basically on time series data, if you're familiar, basically like the stock market, like a trade feed is time series, right? They can in plain English create me a chart on blah 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 on this portfolio XYZ based on the last 3 days and predictions for the next 2 weeks or something, right? That's what they did. So they were able to create that first. They were able to use models that we provide to actually generate code to create the code to build the application, right? Really neat. And they were able to reduce the time on creating charts and summary tables by over 75%. So like that's super impressive, right? And this actually was this was built on Anthropic's Claude model, and there's a video. If you go to their site, you can watch that video and kind of actually see this in action. So the next slide is simply what we have from not doing a marketing pitch, but AWS has basically a multi-model playground. You're not locked into a model. Some companies have their model and they're pushing their model, and it's they're great models, nothing against them, but there's one, right? We have Amazon has a model called Titan that they use, as Ron mentioned, on Amazon.com. But you can pick Anthropic, you can pick Cohere, you can pick different types of models, right? For your fit for purpose. So I mentioned it earlier, not every model is equal. You pick the right model that's right for you. And then, and there's a little playground. So you can go in and ask us some questions. We'll actually generate API calls to show you how to use it. It's really great, but it essentially is AWS's view, again, John kind of summarizing it, is we want to be like the the neutral Switzerland of the AI, ML, generative AI, wars, right? And we're going to offer everything to everybody. Your data is already in there, as Morale mentioned. If you're on AWS, the AI models are right there. They're secure. We don't look at your data. It stays within your VPC if you're familiar with that construct. And it's not used for other customers' benefit. It's only used to improve the value of your business and your model. So with that, I am done, and I appreciate you for the time. So thank you.